Hello everyone, I am Fiorella Sibona and with this video I will provide some details about what I've been working on during the past year and where I intend to direct my research in the coming years. First of going into the details of my research, it is fundamental to provide the context within which the research is brought on and the motivations behind it. It is pretty clear that the industry sector is one of the sectors that has undergone deep transformations. In particular, digitalization and improvements in data processing and manipulation have enabled the possibility to implement industrial plants free from classical, rigid constraints. The industrial environment now requires to be dynamic and productivity-oriented, introducing the need for flexibility. In this view, robots enter a human operator's working space, which of course implies a higher effort towards safe solutions. In addition, the productivity focus requires a smooth synergy among the available robotic systems. So, when considering the introduced context, we need to visualize the industrial scenario as a composition of heterogeneous robotic systems, sharing the working space with human operators, and define optimization accordingly. But why optimization? Well, in this case, optimizing means taking all the elements making up a production line and, for example, achieve resource saving, like time and energy. Optimization also means to take into account all the available information to ensure an overall safe behavior, and last but not least, providing an optimized behavior means improving production performances and resilience to unexpected faults. The goal of my research path is to investigate the role of each subsystem in the industrial scenario when trying to achieve optimization. Another aspect to consider is that automation implies sensors. Sensors generate data, and data can be processed and most importantly should be interpreted to take advantage of meaningful information. This information may give an insight about how and where in the system should actions be performed to achieve optimization. The research brought on so far has focused on the role mobile robots have in the implementation of the flexibility requirements of production lines, where robots and human operators coexist. In particular, when considering traditional industrial settings, we usually find automated guided vehicles, AGVs, that follow predefined fixed paths. The concept introduced in the reported journal paper is that of having a fleet of autonomous mobile robots, AMRs, acting as a support to AGVs, integrating their knowledge about the environment. In this work, a high-level description of the metasensor system architecture was given. But what is a metasensor AMR? A metasensor AMR is an AMR that becomes a sensor itself. The concept of metasensor AMR or SentryBot has been implemented and validated on a laboratory demonstrator, equipped with a laser rangefinder and a simple low-cost IP camera, and containerized using Docker to enable portability. The video source is fed to the real-time object detection system YOLO, which allows the metasensor to perform the detection of persons using a standard dataset. Sensor data fusion maps the bounding box information with the corresponding laser distance, and using the framework ROS, the inflation radius assigned to the detected human position is set to be higher with respect to other generic obstacles, so that the human obstacle is avoided conservatively. This implementation stresses the fact that a smart choice of heterogeneous sensors coupled with advanced algorithms can make up for the lack of high-end smart sensors. For what concerns decision-making in the SentryBotnet, the coalition formation rules and task allocation policies depend on a priority index computed considering the level of criticality of the area to be monitored and the human-detected behavior. Each SentryBot is associated with the task it is currently pursuing and its priority index. Some case scenarios have been tested within an industrial-like simulated environment in Gazebo to showcase the expected behavior of the SentryBotnet. We also investigated the possibility of emulating the standard AGV prefix travel path by computing a virtual safe path whose recomputation is triggered if a human operator presence is detected. A supervisory planner imposes this set of waypoints to the mobile robot, allowing for a more predictable, thus safer motion. Then, what's next? Well, the work done so far will be taken into account as a building block to a more complete system optimization. And among future research, I'd like to deepen my knowledge and investigate techniques aiming at improving the current industrial setting. I'll try to identify relevant parameters to optimize the overall system performances in terms of safety and production, without leaving out sustainability in terms of energy consumption and in terms of obsolete equipment upgrade. That is all. I'd like to thank you for the attention.